Hello everyone. For today's mathematic discussion, we will be discussing about Chapter 4 matrices. So firstly, let's discuss about what matrices actually is. A matrix is a rectangular array of numbers or other mathematical objects for which operations such as addition and multiplication are defined. Most commonly, a matrix over a field, let's say F, is a rectangular array of scalars, each of which is a member of F.
Okay, what is the advantages of matrices?
Okay, the advantages of matrices are matrix algebra is doubtlessly among the most powerful of mathematical tools that are available for the analysis of linear networks. The advantages of matrices for our present purpose are that in a set of linear differential equations, all the variables of one kind can be represented by a single symbol and also all the parameters of each kind. The set of equation is thus represented by a single equation. The solution can be expressed in the same symbols, and matrix algebra given us a routine procedure for finding the solution. Since matrices can be multiplied together according to simple rules, they form an ideal tool for affecting linear transformations. Besides, matrix transformation can be represented in an actual matrix type of array on the panel. Today, we're going to solve this question from Chapter 4 Matrices. Ranon, can you read
Okay,
out the question?
costumes are needed for the school annual day function. Singer's costume required 4 yards of fabric, 2 yards of ribbon, and 1 packet of sequins. Drama students' costume required 9 yards of fabric, 3 yards of ribbon, and 1 packet of sequins. Dancer's costume required 12 yards of fabric, 3 yards of ribbons, and 1 packet of sequins. Singer costume cost 18 ringgit. Drama student costume cost 31 ringgit, and dancer costume cost totally 37 ringgit. Find the cost of each yard of fabric, each yard of ribbon, and each packet of sequins. Okay, Sharon, can you show me how to solve this question?
Let me show you how to solve this question. To solve this question, we will be using matrices method, which is inverse matrices. To solve this question by using inverse matrix method, we have to transfer the data into a system of linear equations. Hence, let Z be the cost of fabric, Y will be the cost of ribbons, and X will be the cost of sequins. By doing this equation, we will obtain three linear equations, which is x plus 2y plus 4z equal to 18, x plus 3y plus 9z equal to 31, x plus 3y plus 12z equal to 37. It will be easier for us to converting it into matrix form when we transferring the data into a system of linear equation. Then we will solve this equation by using inverse matrix. First, let's transfer the matrix coefficient into the Ax equal to B formula. So, the formula Ax equal to B will be pre-multiply both sides by A inverse. So, we will get x equal to inverse A multiply with B. To find the inverse of matrix A, first, we have to find the determinant and cofactor. To find the determinant of A, we will expand the first row, so we will get 1. We will cancel the first row and the first column. We will get 3, 9, 3, and 12. Then minus with 2, we will cancel the second row, the first row, and the second column. We will get 1, 9, and 1, 12. Then we plus with 4. We will cancel the first row and third column. and we will get 1, 3, and 1, 3. So we will get the answer 3. And then we will find the cofactor. To find the cofactor, we will change the signs positive, negative, and positive at the first row. And for the second row, it will start with negative, positive, and negative. And the third row will start with positive, negative, positive. Then we will get the cofactor 9, negative 3, 0, negative 2, 8, negative 1, 6, negative 5, and 1. Then we have to find the adjoint of A. To get the adjoint of A, we have to transpose the cofactor. So we will get 9, negative 12, 6, negative 3, 8, negative 5, 0, negative 1, and 1.
Okay.
The last one, we can find the inverse of matrix A by using the formula inverse A equal to 1 over determinant of A multiply with adjoint A. So we will get the answer 3, negative 4, 2, negative 1, 8 over 3, negative 5 over 3, 0, negative 1 over 3, and 1 over 3.
Okay.
And finally, we can get the x inverse of A multiplied with B. So the inverse of A, we will multiply with B from the equation that we already done at the first step. So we will get x equal to 4, y equal to 3, and z equal to 2. Thus, thus, the conclusion is a yard of fabric is 2 ringgit, a yard of ribbon equal to 3 ringgit, and a packet of sequins equal to 4 ringgit.
Oh, thank you, Sharon, for the explanation. Okay, now I understand. Where are the matrices used in daily life?
Matrices or matrix is commonly used in mathematics, but have you thought about how important it is or where you can use it? Ever wonder where the word matrix comes from? Matrix is actually a Latin word used for the womb. It is also used to express something that is formed or produced. The matrices are used a lot in daily life, but its applications are usually not discussed in class. Therefore, we have brought to you the importance and the application of math through matrices in a simple form. Example of matrices uses. Number one is encryption. In encryption, we use it to scramble data for security purposes. To encode and to decode this data, we need matrices. There is a key which helps encode and decode data which is generated by matrices. Number two is construction. Have you seen some buildings are straight, but sometimes architects try to change the outer structure of the building like the famous Burj Khalifa? This can be done with matrices. A matrix is made of rows and columns. You can change the number of rows and columns within a matrix. Alright then, does everyone have a clear explanation about what matrices is and how it can be used to solve problems in our daily life?